Spring so Excel. Hi everyone, today I would like to present how to use the Bessel method and Everett formula to solve the interpolation and polynomial construction. So look at our example 1. The question say use the 4-digit rounding to construct Bessel method and Everett formula approximation to f 1.09. The function being approximated is fx equal to log 10 tan x. The value of x and fx is given by the question as follows. So the step 1, we need to mark down our x is 1.09, which is given by the question, and x naught is 1.05. Since this value is the most closest to the value of x, then h naught, which is equal to 1.05 minus 1.00, then we will get 0.05. Then h1 equal to 1.10 minus 1.05. The value of h also 0.05. Then last we need to find the h2, which is 1.15 minus 1.10. Since the value of h0, h1 and h2 is the same, which is 0.05, then we can conclude that h value is stand for 0.05. Then we go to find our p value. The p formula is x minus x naught, then divided by the h value. So insert the formula into Excel, which is equal to bracket x minus x naught bracket divided by h, which is 0.05. Then the p value is 0.8. Then we can insert our data into the dividend difference table. So since xi is insert as x data and fxi is insert the data of fx, so x naught is 1.05, so the I for 1.05 is 0, so the 1.00 for the I is -1, then 1.10 is 1, and 1.15 for the value of I is 2. Then we continue to start for finding the first DD value. So for find the first DD minus 1, which is orange color, then we can insert the formula, which is equal to 0.2414 minus 0.1924. So we get the answer 0.0490. Then followed by first DD 0, which is yellow color, equal to the 0.2933 minus the 0.2414. Then followed by first DD 1, equal to 0.3492 minus 0.2933. After the first DD, continue by second DD. The second DD minus 1, which is blue color is equal to yellow color minus the orange color, which is 0.0029. Then continue to find the value of second DD 0. So equal green minus the yellow. So the value of second DD 0 is 0.0040. So continue with third DD minus 1 pink color, which is equal to purple minus the blue color. Then for third DD minus 1 is 0.0011. After complete the table of the dividend difference, then we continue for find the exact value. Since the question already give the exact function, which is f x equal to log 10 tan x, then we substitute x to 1.09. So insert the formula equal to log 10 bracket tan bracket 1.09 bracket, then we will get the answer 0.2826429114. Since the question did not require how many digit rounding in exact value, so I place it at 9-digit rounding. Then continue with to find the approximation by Bessel method. The formula to the Bessel method is like this one, so we need to insert the value inside the formula. So equal to y0, which is this one, 0.2414, plus with p times first digit 0. So first digit 0, p is 0.8 times with first digit 0 yellow color, then plus with bracket p 0.8 times bracket p minus 1 0.8 minus 1 bracket then divided by 2 factorial, which is 4, then times again with second digit minus 1 plus second digit y0, which is blue and purple color. So we can bracket blue plus purple bracket divided by 2, then plus again bracket p minus 1 over 2, so 0.8 minus 0.5 bracket then times to p again 0.8, then times again to bracket p minus 1, which is bracket 0.8 minus 1 bracket then divided by 2 factorial, which is 4 also, then times with the last number, which is third digit minus 1, which is pink color 0.0011, then enter. We will get the answer of 0.2827688. Since the question asks us to round the approximation value to 4-digit rounding, so we can write as 0.2828. After find the value approximation value by some method, then we try to find the absolute value. The absolute value formula is exact value minus the approximation value, then modulus them. So equal to 0.2826429114 minus 0.2828. Since the value is negative, so we need to add on the minus and bracket inside. Therefore, the answer will become positive number. So the absolute value is 0.00015786. After that, we need to find the relative error. The relative error formula is absolute value divided by the exact value. The last answer also will need to modulus, so we will get the positive number. So insert the formula is equal to absolute value divided by the exact value, which is 0.282642912914. enter, then the answer is 0.000555775. Then we also can write like this: 5.55775 times with 10 to the power of -4. Then compare with the 5 times 10 to the power of -t, we can say that t equal to 4. So we can make a small conclusion, which is approximation by Bessel method was accurate to 4 significant digits. So for the approximation by Bessel method is complete, then we continue by the approximation by Everett formula. The Everett formula is like this. Before start insert the formula, we need to find the Q value. Q value formula is 1 minus P, so equal to 1 minus, above P is 0.8. So enter, then Q is 0.2. So we can start for insert our formula into the approximation by Everett formula. So equal to Q, which is 0.2 times y0, which is 0.2414. Then we will look plus with q times q squared minus 1 squared divided by 3 factorial, then times with second dd minus 1. So we need to bracket q times bracket q square minus 1 square bracket back, then divided by 3 factorial, which is 6, then bracket again, then times with second dd minus 1, second dd minus 1, blue color. Okay, then we plus again to p times y1. So the p is 0.8 times y1 is 0.2933. Then we plus again with p times p square minus 1 square divided by 3 factorial, then times with second dd y0. So we need to bracket p 0.8 bracket 0.8 square minus 1 square bracket divided by 3 factorial, which is also 6, then times again with second ddy0. Second ddy0 is purple color. Then we bracket back. So just enter. Wait. Something wrong. 0.24 q times y0 yes, plus with q times q square minus q bracket maybe I can do. Okay, so we will get the answer for approximation by Everett formula f 1.09 is 0.2826352. since the question asks to 4-digit routing, then we need to write like 0.2826. So the absolute value formula also the same exact minus the approximation then modulus, so equal to exact value, which is 0.2826 for 2914 minus 0.2826 enter. Then the absolute value is 0.0004291400. Then we continue to find relative error, which is equal to absolute value divided by the exact value, which is 0.2826 for 2914. So enter. Then the relative error for the approximation by Everett formula is 0.0001511831. Then we can write like this. So 1.51831 times with 10 to the power of -4. So this also compare with 5 times 10 to the power of -t, so t equal to 4. So the conclusion is approximation by Everett formula was accurate to 4 significant digits. So the approximation by Everett formula is complete, and that's all for the solution for example 1. And thank you for looking the solution and listening. Pause.